All right, hi guys. I didn't want to add this to the notes. I didn't want to make one video that was too long, make it seem overwhelming. So I did a separate video here to go over the example problems. The first worksheet that we have this week has 5 example problems, and so I'm going to take the time to go over those 5 example problems that are all very similar to problems that are on the worksheets itself. All right. So example 1, we want to find the angle of elevation, which we should have just learned is the angle that's going up. So here's our angle of elevation here. Okay. So the angle of elevation, so that's what we're looking for. So that's x. If you are standing 400 feet away, so we're standing 400 feet away from the base of the building, and then we know the building is 850 feet tall. Okay, so if you look up at the step-by-step process for solving these, one is draw a picture. That's already drawn for us. Step 2 is label the parts. So our hypotenuse would be this side here, across from our right angle. Across from the angle, and we're going to circle the angle. Across from that angle is your opposite. Next to that angle is your adjacent. So we have adjacent and opposite. Okay, so again, we're using SOHCAHTOA for all of these problems. Right, SOHCAHTOA. All right, we have adjacent and opposite, so that's going to be tangent, right? The O and the A. So we're going to use the TOA part, which is tangent. So the next question we have to ask ourselves is, are we solving for a side or an angle? And in this case, we're solving for an angle, so we have to use the inverse trig functions. So we're going to use inverse tangent. So tangent inverse. Okay, and you input the ratio, right? Regular tangent, you'd input the angle, and it'd give you a ratio as an output. Here we're inputting the ratio, so our ratio is opposite over adjacent. So that's going to be 850 divided by 400. That's going to be equal to our angle, which in this case is x. So we go to our calculator, we make sure we're in degrees. Okay, and we're going to do inverse tangent, 850 divided by 400. Remember, arctan is the same as inverse tangent. Right, and then we hit enter, and it's telling us 64.79, so basically 64.8 degrees. So 64.8 degrees. All right, that's approximately the angle of elevation. Okay, so we're looking up, whoever's standing here, in this case it would be you. You are standing here at the bottom, looking up at an angle of 64.8 degrees to see the top of the building. Okay. Example 2, from the top of a tower. Okay, so there's a tower. The angle of depression to a stake on the ground is 60 degrees. So we have a tower. Okay, so the top of the tower is up here. The angle of depression, so we need to, I would draw in our horizontal. Okay, and then there's a stake in the ground. The angle of depression from the top of the tower to the stake in the ground, so that's going to be this right here, is 60 degrees. The top of the tower is 80 feet above the ground. How far is the stake from the foot of the tower? So the foot of the tower means the base of the tower. So we want to know how far is the foot of the tower from the base. Okay. So we know that the horizontal here and the ground are going to be parallel lines. So our alternate interior angle theorem tells us our alternate interior angles are going to be congruent because the lines are parallel. So that's 60 degrees down there, right? Alternate interior. We now need to label the sides. So the hypotenuse is this side right here across from our right angle. We're looking at 60 degrees. 80 is across, so that's opposite. X is next to, so that's adjacent. So if we're looking at SOHCAHTOA, we have opposite and adjacent, so that's going to be tangent. So tangent of the angle. All right, and the question we ask ourselves is, are we solving for a side or an angle? We're solving for a side, so it's going to be regular tangent. So tangent of 60 degrees equals opposite over adjacent, so that's going to be 80 over x. Then we have to solve for x, so we multiply x on both sides. You get x tangent 60 equals 80, and then you can divide both sides by the tangent of 60. Those cancel, and you get x is approximately 80 divided by the tangent of 60. So we go to our calculator. 80 divided by tangent of 60. And you're going to get 46.2 meters, I believe, right? Feet. Approximately 46.2 feet. Okay, that's this distance here from the base of the tower to the stake. Okay, example 3, a ladder leaning against a house makes an angle of 30 degrees with the ground. So we have a house, right? There's a house. There's a ladder leaning against it. So here's a ladder leaning against the house. It makes an angle of 30 degrees with the ground. So here's the ground. It makes an angle of 30 degrees. The foot of the ladder is 7 feet from the house. So this distance here to here is 7 feet. And we want to know how long the ladder is. So I'm going to put it in X there. So we have our drawing. The next step is to label our side. So across from the right angle is your hypotenuse. So that's X. The 7 is next to the 30 degrees. So that's adjacent. So if we use SOHCAHTOA, we have adjacent and hypotenuse, which is going to make it cosine. So we're going to do cosine, and we're solving for a side. So we're going to use regular cosine. So cosine, and we input our angle, which is 30 degrees, equals adjacent over hypotenuse. That's going to be 7 over x. Multiply x on both sides. Right? X times cosine of 30 equals 7. And then we can divide both sides by cosine 30. That cancels, and we get x equals approximately 7 divided by cosine of 30. You make sure you're in degrees, and we get 8.1. Okay, so it's going to be approximately 8.1 feet. That's not the biggest ladder in the world, but it's not the smallest either. Okay. So the length of that ladder is 8.1 feet. All right, example 4 here. All right, you're a block away from a skyscraper that is 780 feet tall. Your friend is between the skyscraper and yourself. So there's you, there's your friend, there's the skyscraper. The angle of elevation from your position to the top of the tower is 42 degrees. The angle of elevation from your friend's position to the top of the tower is 71 degrees, this angle here. To the nearest foot, how far are you from your friend? So we want to find this distance right here. So what I see immediately is 2 right triangles. I see this big one here. All right, so I'm going to draw that one out over here. Okay. 42 degrees is the angle of elevation. We know the tower is 780 feet tall. All right, and here's our right angle. Right, and then I also see the blue one, which is the smaller one. Right, so this one's much smaller. Okay, this is 71 degrees. Here's our right angle. We know the tower is 780 feet tall. Okay, so we want to find this piece right here. So let's call the bottom of the green one x. So that's this distance here is x. All right, and then we're going to call the base of the blue triangle here y. Okay. So if we want to find the distance between you and your friend, we need to find x and y, and then we need to do x minus y. Okay, so let's first try and find x. Okay, we want to label the hypotenuse. That's the side across from the right angle. We want to circle the angle in question. Across is opposite, so 780 is opposite. Next to is adjacent, so x is going to be your adjacent side. We're going to use opposite over adjacent, right? So if you go to SOHCAHTOA, opposite and adjacent here is going to be the TOA part, so that's tangent. So we're going to do tangent of the angle, which is 42 degrees, equals opposite over adjacent, so 780 over x. All right, we're going to multiply x on both sides. Right, and then you get x times tangent 42 equals 780. And then we're going to divide both sides by tangent 42. These cancel, we're left with x on the left side, and then 780 divided by tangent 42. So 780 divided by, make sure in degrees, tangent 42. That's going to be 866.3. So it's approximately 866.3 feet. 63, right? 67, 66.3 feet. Okay. And then let's find y now. So x, that's the whole distance across. That's how far you are from the building. So you are standing 866.3 feet away from the building. Let's see how far away your friend is standing. So we got to label his triangle. The hypotenuse is across from the right angle. Okay, across from the 71 is the 780, so that's opposite. Okay, and then next to the 71 is the y, that's going to be adjacent. Okay, so let's see if we can't solve that one. So I'm going to erase all this so we have room. We currently don't have the room. I'm going to leave the y down there though. I mean the x down there though. All right, so we have opposite and adjacent, that's tangent again. So we're going to do tangent of 71. Okay, equals opposite over adjacent. So that's going to be 780 over y. Okay, multiply both sides by y. You get y times tangent 71 equals 780. And then you divide both sides by tangent 71. All right, so you get y is approximately 780 divided by tangent. Make sure in degrees, 71 degrees. Okay, it's going to give you 268.6, 268.6 feet. Right? Yep. So you're standing 866.3 feet away from the building. Your friend's standing 268.6 feet away from the building. So if we take that whole distance and subtract your friend's distance, you should find the distance between you and your friend. So we do the last step here. 866.3 minus 268.6. So 866.3 minus 268.6. And we get 597.7. So you are 597.7 feet away from your friend. 597.7 feet from your friend. So you had to find the whole base using the big triangle, that was X. You had to find the small base of the blue triangle here, which we called Y. Once you had X and Y, you could find the difference there, and then that would be how far you were standing from your friend. Okay. Last example on here. Sometimes you need to add lines to your drawings to create right triangles. They want us to find BC. Okay, so I'm going to call that X. We can't use any of our methods right now because we don't have right triangles. So what we can do here is draw in an altitude. Okay. Right, and then we can first find whatever that altitude is. Right, so we know, again, if we want to redraw this triangle, here's our right angle. This is 250 degrees, or 250 feet, I'm sorry, 250 feet. This is 42 degrees. Okay. And we want to find what we called Y here. Okay, so we're again going to use SOHCAHTOA. We're solving for a side, so it's going to be regular trig. So across from the right angle is a hypotenuse, so that's going to be 250. We're looking at the 42, so across from the 42 is going to be your Y, so that's opposite. So we're going to use opposite hypotenuse, that's sine, so the sine of 42 degrees is going to equal opposite, which is Y, over hypotenuse, which is 250. Okay, multiply 250 on both sides. So 250 times the sine of 42. So 250 times sine 42. Make sure you're in degrees. Okay, we hit enter and it's going to be 167.3. And that's going to be feet is approximately Y. Okay, but we're not looking for Y, we're looking for BC. So we need to do a little bit more. We know the three angles of a triangle add up to 180. So we can do 180 minus 90 minus 42. And that's going to give us 48. So we know this angle here is 48. All right, if we know this angle here is 48, and we know the whole thing, right, this entire thing here is 110, we can do 110 minus 48. Okay, and that's going to be 62. So if we draw that second triangle, this triangle, right, it's going to look like this. Let's do a little better. There's your right angle. Okay. We want to find X here, which is BC. The altitude we solved already was 167.3. So this is 167.3. Okay. And then we just solved here that this angle is going to be 62. So this angle here is going to be 62 degrees. This one was 48, right? We found it by doing 180 minus 90 minus 42 gave us 48. Right, 90 and 42, so the other one has to be 48. 110 minus 48 is going to give us 62. All right, we can now label our side. So x is the hypotenuse. It's across from the right angle. This is the angle in question. 167.3 is next to, so that's adjacent. Okay, since we have adjacent and hypotenuse, we're using cosine. So it's going to be cosine of the angle, which is 62 degrees, equals the adjacent over the hypotenuse. So that's 167.3 divided by x. We want to solve for x, so we need to get it out of the denominator. So we multiply both sides by x. So you have x cosine 62 equals 167.3. You can divide both sides by the cosine of 62 now. And we get left with x is approximately, so 167.3. That was that answer right there, but that's all right. 167.3 divided by cosine 62. Hit enter and it's going to tell us 356.4. So it's approximately 356.4 feet. That's the approximate length here of BC. Okay. All right. So those are the 5 example problems they give you. Some of them are duplicated on the assignment. So let me know if you have any questions on those. I will also make a walkthrough for this where I kind of just sketch out and draw the triangles and kind of verbally go over what you're going to do.